So now, essentially, we move to the panel discussion, which is moderated by Enrico and Natalizio. And after the panel, there will be the announcement of the Best Paper Award. Okay, so please, Enrico.
Hello, everybody. Welcome to the R2T2 panel on the present and the future of robotics. So as Julia said, my name is Enrico Natalizio. I'm the principal researcher for the communication and networking team with the Autonomous Robotic Research Center of the TII. And before introducing our distinguished panelists, I would like to thank all the TII staff who participated in preparing this panel, both technicians and researchers. And I would like to introduce the audience also with the panel of today by starting with a quote from Garry Kasparov, the chess grandmaster and the first world champion beaten by a computer. So Kasparov, in one of his recent public speeches, he said, what I learned from my own experience is that we must face our fears if we want to get the most out of our technology. And we must conquer those fears if we want to get the best out of our humanity. While licking my bones, I got a lot of inspiration from my battles against Deep Blue. As the old Russian saying goes, if you cannot beat them, join them. So even only from these 2 days of event that we had, we have seen that in our near future, it's easy to imagine that we'll have cell-size injectable micro-robots, plant-based robots, self-driving cars, fleets of aerial and marine drones, and they will take over the water, the land, and the sky to replace humans in complex or tedious tasks. So the question now is, how will we get there? What is the role of the different disciplines which are involved, like control, vision, robotics, communication, artificial intelligence, and so on? And how will they interact to lead to this progress? Then how much autonomy should we grant to the multi-robot system of the future? And which will be the technological research ethic challenges that this system will pose in the next 10, 20 years? So is in the end, Kasparov right in thinking of us, the humans, willing to join forces with them, the robots? So we will discuss this and other issues with our distinguished panelists that I'm going to introduce now. So our first alphabetically ordered is Vikrant Aggarwal. Hello, Vikrant. Just can you unmute yourself and say hi so that everyone will know?
Yes. Good evening, good morning, good afternoon, depending upon wherever you are. Enrico and team, thank you for having me on the panel.
Thank you, Vikrant. Vikrant is the president of Local Motors, which is a ground mobility company focused on shaping low-volume vehicle manufacturing of open source design using multiple microfactories. He brings with him more than 20 years of automotive and industrial experience, managing and growing successful global businesses. So yeah, unfortunately, I don't have with Zoom the scenic effect of inviting you on the stage. You can always go walk from your sofa to your chair if you want. Huh? So the next one is the next one is Mérouane Debbah. He has been vice president of Huawei France Research Center since 2014. Currently, is the director of the Mathematical and Algorithm Science Lab, as well as the director of the Lagrange Mathematical and Computing Research Center. His research interests lie in fundamental mathematics, algorithms, statistics, information, and communication sciences research. When I tried counting all the awards and prizes obtained by Mérouane, I got lost in counting several times from his bio.
Thank you for inviting me, and I'm very happy to be here, and especially quite impressed by the settlement of TII within this very short time. Congratulations for all the work that you're doing.
Thank you, thank you. So next panelist is Gusz Eiben. He's a full professor at the Vrije Universiteit Amsterdam. Sorry for the pronunciation, my Dutch is not the best, I think, where he leads the computational intelligence group with more than 30 years of experience. His research focuses on artificial intelligence, artificial life, and adaptive collective systems. He works on evolving and learning machines that reproduce, improve themselves, and develop intelligence over time. His most prominent endeavors in this direction include the Robot Baby Project and the Autonomous Robot Evolution Project. Welcome, Gusz.
Thank you very much for having me. Allow me to repeat the compliments. The TII is really an exciting Institute, and this is a very nice conference. And in case you were wondering, my background is artificial. I am in Amsterdam, where it is rainy and stormy, and I was just so envious of some of you who are in sunny locations that I had to introduce this to make myself feel better.
Okay, thank you, Gusz. So next panelist is Costas Pelicanakis. So he joined the Center for Maritime Research and Experimentation at the NATO Science and Technology Organization, where he has become a senior scientist in 2018. His research lies in the areas of robust signal processing, security, adaptive underwater acoustic communication, and networks. Costas has about 15 years of experience in conducting sea trials, and in 2018 he was awarded the NATO Scientific Achievement Award for contributing to the development of Janus, the first digital underwater communication standard. Welcome, Costas, and thank you.
Thank you, Enrico. Thank you for the invitation. It's a pleasure and honor to be among these distinguished panelists. Also, congrats to TII for pulling this event so fast and quickly and in great success.
Thank you, Costas. And the last in alphabetical order is Davide Scaramuzza. He's a professor of robotics and perception at both Department of Informatics at the University of Zurich and the Neuroinformatics that is a joint between the University of Zurich and ETH Zurich. Here he directs the Robotics and Perception Group. His research lies at the intersection of robotics, computer vision, and machine learning. And again, the awards and recognition for Davide will definitely be too many to be listed now, but it should be sufficient to say that Davide is so famous in his field that besides all the academic exposition, many aspects of his research have been prominently featured in wider media, such as the New York Times, BBC, Discovery Channel, and so on. So welcome and thank you, Davide.
Hi guys, nice to be here.
Yeah. So just some information to start the panel today. It will be split in two main parts. So that the first will be focused on the present of robotics. So the question that I'm going to ask you are more related to the situation right now. And the second is more on the future. And also I will have some collective question, let's say, or at least for a couple of you, and some more individual questions. All the other speakers, I see that they are like with the camera off and with they are muted. So thank you very much. Keep like that if you can. I'm not sure. I don't think that we'll have time to get questions from the audience, but feel free if you want to comment in the question and answer tab. So let's start with the present. And I have the first question for Mérouane, and we'll go in this order. And for Gusz is, can you highlight two key facts in your field of activity related with the present of robotics? Mérouane.
Indeed, I think I've been working in the last years on this convergence of what we call communication and computing. And I think robotics is exactly at, I would say, this interdisciplinary research. And so basically today, I think the two things which are important for us in terms of designing in a very good manner is basically the protocols that can be embedded for these robots in terms of, I would say, distributed intelligence, and for them to work in a more distributed manner. And second, which is very important, is all the work which is being poured in today on what we call on-device AI, or let's say portable AI that you can embed. As you know, the majority of work that has been developed these last years were mostly around topics of cloudification of AI with centralized data learning, and then you do inference directly on the device or the robot. And today what's happening is that people want to do training and inference directly on the robot or the device. And basically this is a big game changer in terms of complexity that we're pouring in, where the classical frameworks that are being used, call them TensorFlow, call them Apache, are more cloud oriented than having what we call more pervasive approach. And second, also the hardware that needs to be built in terms of chipset to be able to do it directly on the robot requires more, in fact, taking into account the architecture, basically, lowering, for example, the precision of the AI so that you can have enough energy for the robot to move, things like binary neural network, low precision AI. So in a summary, the two directions are the protocols that have been built so far are mostly done for things with very few intelligence in them, okay? And therefore we need to find out what are the protocols that we can build for communication, which are intelligent things, and robots are part of that. And the second, I would say, axis is this new trend of bringing more intelligence and computing towards the device, and where you need to do much smarter distributed AI algorithms. Federated learning are part of that, for example, and you have a broader point of view. So these are the two directions, and of course, for the future, they're encountering new things. For the protocol, 6G is in that direction of looking at more or less protocols for intelligent things, and that's the trend to go. And the fact that we're pouring more and more pervasive AI while you're trying to find this connected intelligence and how you can put basically platforms for that.
Mm-hmm.
I'll stop here because
yeah, already, good, very good input, and I can testify that to bring the intelligence into the robot and all the training and the testing is something that we're actually also trying to do at TII. So we are going in that direction. Good to know. Then, Gusz, same question. Two key facts related to your field of activity.
So I will start with a hypothesis or wish, if you will, and that is, so considering that evolution can produce intelligence, and we are all part of the evidence for this fact, okay, it is very plausible that artificial evolution could produce artificial intelligence. Now, the robotic version of the same thing would be like, if you look at life on Earth, you will see that evolution successfully populated all different environmental niches on Earth. There is life everywhere. And if you take this, then you would also hope and wish and hypothesize that artificial evolution could produce robots for all kinds of environments and tasks and conditions. Now, this is, so far it's only a dream. Now, you asked me for a fact. Now, the fact is that evolution can indeed do that, and evolution is capable of delivering us optimized or well-designed robot morphologies / bodies and the corresponding robot controllers / brains. And in 2 to 3 years, we will be able to do this on the real hardware. So the current way of working is you evolve something in simulation, and sometimes at the end, when you are ready, you manifest or manufacture the end product of evolution. But the process of evolution takes place in simulation. This leads to huge problems known as the reality gap. And the good news is that the reality gap can be circumvented by the new convergence of technologies like 3D printing, automated assembly, new materials that are used for sensing and actuating. And maybe so the breakthrough is here within 2 to 3 years, and a bigger rollout could be between 5 to 10 years when evolution will be the designer and the manufacturer of robots. Fact number 2 is, this may be less known to all of you, is I put it as one punchy one-liner. If it evolves, it needs to learn. So by the inherent nature of robot evolution, the robot children will have a different body than their parents. And even animals where the offspring has the same kind of body, 4 legs and a head and 2 eyes, they still have to learn to manipulate their bodies. And human children need 18 years to do everything what the parents can do. And if a robot evolutionary process produces different children with different number of limbs, wheels, legs, heads, whatever, it will be even more necessary. So the statement or the fact is that a newborn robot will have to undergo an infant learning process to optimize its brain to its completely new body. And this also can be done on the real hardware, or similarly to Mérouane, indeed. On the robot, it can be done, and this will be the key to improve the inherited brain and get the maximum potential out of that robot. And in the end, all this, to summarize, will lead to a new breed of machines that can change their form and function, not by error, but on purpose, by design. And that will be a great game changer.
Yeah, thank you. It's very visionary, and I think we started very well with two good direction for discussion. So next question for Vikrant, Costas, and Davide in this order. So I'll start with Vikrant. Is can you identify the most relevant, in your case, industrial current hindrances to a mass utilization of robotic devices?
Yeah, so firstly, Enrico, once again, thank you for the opportunity, and I'm humbled by this invitation, but also want to recognize the team that sits behind me. You know, I do this work not by myself. So just to answer your question, I think I would actually just maybe answer the question a little bit differently. I wouldn't say these are the hindrances, but these are the evolutions we have to go through in mass utilization of robotic devices, right? The number one is, and this is in no particular order, is legislation and regulation, right? They have to allow and evolve both from a legislative framework, but also from a regulatory framework to go deploy robotic devices. The second is the technological advances and evolution that has to happen. How do we make, as in terms of autonomous vehicles, as an example, you know, how do we develop technology or evolve the technology that's already been developed such that we can run it stewardless, as an example, right? So Vikrant is not running the shuttle or sitting in the shuttle as a safety device, okay? And the third, in my mind, is the user mindset, right? Those of us, or many of us, who are growing up or have grown up in the current environment, we are used to dealing with humans. We trust ourselves sometimes more than we trust the machines, right? And so those three, at a minimum, have to evolve and come together for mass utilization of robotic devices. And I think, if I were to say hindrance, you know, if I were to just flip that around, Enrico, I think the biggest of those three in my mind is not having a common view around what is the legislative and regulatory framework to move things in a much more cohesive fashion, right? And we all live in the real world. There's never a global standard. Every region or every country wants to do their own things. But, you know, for instance, if you just look at our mobility solution, there is no classification for the vehicle that exists today, okay? And it will take the legislative folks probably a few years to even come up with a classification of that vehicle. So I think those are the three, I would say, opportunities or hindrances, depending on how you look at it, whether you're a glass half full guy or a glass half empty gal, right? So that is my short answer to what I think are some of the things that need to happen for mass utilization of robotic devices.
Yeah, very good, Vikrant, because yeah, you put on the table the other aspects more related to social, political, and human that are less, let's say, technological, or so it's important as well. Thank you. So Costas, same question from your point of view, current hindrances.
So since I come from the ocean domain, and I will focus mainly on the ocean domain. Hindrances for mass utilization in the ocean. Let me distinguish between whether we talk robots that stay on the surface or robots that go underwater. When we are talking about robots that stay on the surface, that's a, let's say, relatively easy thing to do, because you have GPS, you have satellite comms, you have RF comms, so you can easily understand where you are on the surface. It's a 2D navigation problem. It's not a 3D navigation problem. So I would say that mainly the cost is the main hindrance when you go to mass utilization of surface robots. Mainly the technological, let's say, challenges are more or less addressed. But when you go to the underwater domain, that is a whole new problem that you need to consider. It's much more challenging because you don't have GPS underwater. You don't have RF communications underwater. You need to, mainly the robots need to rely on their own nav systems, which of course they create errors. They are not very accurate. We're talking about error accuracies in the order of tens of meters, maybe hundreds of meters. So you don't really know where you are underwater. Another issue is that, so if the application requires, for example, very accurate navigation and localization, then this is a technological challenge that needs to be addressed. Another issue is that has some financial implications, is that you can easily lose the vehicle. If something goes wrong, if something, for example, if the software hangs, you can lose the vehicle and it's very, very hard to find it. So that is an issue, let's say an issue of cost, because these vehicles are not cheap. And of course, you don't want to lose vehicles in the sea. Also, of course, underwater vehicles, they have batteries. They need to, you need to recharge them every so often. They don't have unlimited power. So charging the vehicle, and this will create delays in the overall mission. And I will also, last point that I want to make, which is common, either you are on the surface or you are underwater. I will echo what Vikrant says. There is absolutely no legislation when it comes to liability issues. For example, if there is a vehicle, if there is a surface vehicle, autonomous vehicle collides with a ship, what's happening there? Who pays? Or the same happens in the underwater domain. If you have a collision of two vehicles, whose fault is it? Who pays? These are issues, legislative issues that have not been addressed. And if they are not addressed, I don't foresee soon mass utilization of robots, either on the surface or underwater.
Okay, thank you. Yeah, your answer is a mix of the two of them, technical and legislation. Davide, can we help Costas underwater with some vision, and also which are the hindrances that
Yes, can I report first the two facts about robotics that I would like to share? So
yeah, sure.
I've been working on autonomous drones now for 10 years. And before, I actually was working on self-driving cars. At that time, in 2009, I stopped working on self-driving cars because Google announced the self-driving car project. And then everyone, especially the big tech companies and the news, they reported that soon we will have autonomous cars before 2020. As you realize, this is not the case. Of course, we have smart cars. Every car has, line assistance systems, driving assistance systems, and so on, but we do not have. There is one fact, though, that is already true. We have autonomous drones. And never would have thought that actually this small robot species would have become actually, widespread everywhere. There are two companies, one in China, which is DJI, which owns 80% of the market. And then in the US, there is Skydio, which at the moment is a startup, but in 5 years, it had an evaluation of $1 billion, okay? Especially most of the money coming from Horowitz. Now, these two companies are leading the world markets in terms of autonomy. What does it mean for a robot to be autonomous? It means it can move from A to B just using its own onboard sensors and computers. This is the world first, okay? DJI was actually pioneering in that because they were the first to have out a commodity hardware, because it's already a mass product that you can buy and you can move from A to B with GPS or even without GPS. You can fly this under a bridge. Actually, what do these drones do? In fact, most of the services that they serve are actually for inspection. So you can instruct the drone to actually fly at a constant distance from a wall and inspect, for example, a dam, or for example, to fly under the bridge, to inspect the ceiling of a bridge, which is very important. As you know, bridges can fall. Other things that are being used for are for remote sensing. So flying over a crop to determine the status of a crop, using infrared cameras, as well as to fly within the crop to count the number of fruits and so on. This is called the precision agriculture. Also, they're being used now, Scaramuzza, more and more in the US. There are 5,000 drones being used for inspecting solar panels in the US, all autonomously. There is not a single pilot there. Other things, there have been also delivery drones. So in Switzerland, Maritime, which is a Silicon Valley-based company, has already performed more than 5,000 autonomous flights in Lugano, Zurich, and Bern. And Zipline, which instead uses fixed-wing drones, is delivering blood samples in Rwanda. They performed more than 70,000 autonomous flights. So that's a reality. It's a fact. Now, two things about what is hindering these things to become more widespread. I would say they're already widespread. Now, already mass. Of course, mass means everyone is becoming consumer hardware. Well, you can find the drones that are consumer hardware or that you can fly for a few bucks. Now, if you want to have an autonomous drone, of course, what you want to make sure that there is it's robustness. So the problem is that all autonomous mobile robots, both cars and drones, are not very robust when they encounter obstacles like other humans or environments, objects that they did not see. So detecting and also understanding what is happening around the robot is still not possible. Of course, there are a lot of academic papers that are performed in lab environments, but the problem is that getting something from a TRL level of 4, so lab demonstration, into 9, which is, real world deployment, it takes years, because you want to have something that really works 99.999999% of the times. And this can take decades. So of course, for cars, this is more difficult because cars will have to navigate through people. For drones, this is more feasible because most of the drones do not navigate through people, but they actually navigate over people, right? So this is going to be certainly possible. Now, you guys mentioned endurance. You mentioned legislation. Legislations are getting better, fortunately. However, in a reality like Europe, it's still very fragmented. But now, thanks to the new European drone regulations, all the European countries will have to basically comply to the same rule, which basically will allow also autonomous flight even beyond line of sight. Another cool thing is happening in terms of endurance. So there is a large project in Denmark, and there's also there is also a European project called the Aerial Core, which is about using the power lines to recharge drones. So the drones now will be flying along predefined corridors, and the corridors will be along power lines. So the idea is that the drone then docks to the power line and recharges its batteries and then continues for another 100 kilometers. So this is already being studied in Denmark and within the European project Aerial Core. So this will you just have to wait and see. Okay.
Okay, thank you, Davide. It was the right answer to conclude this first general question for everyone. Now we'll go with the more specific one. So the first one will be Mérouane. Yeah, let's try shrink a little bit your large and broad interdisciplinary background and focus on communication and artificial intelligence. What's the role of these two disciplines in robotics, according to your opinion? Unmute yourself.
Well, I think they have a major role, and I think what has been mentioned previously showcases, I would say, the triptych of three things. The first thing is the fact that whatever we build in the future will have to provide sensing capabilities, okay? And these sensing capabilities go with the higher precision. Higher precision goes with higher bandwidths and higher frequencies. And we're seeing it today already. The major, I would say, research underlying the community in wireless in trying to work on millimeter wave and terahertz bandwidth to build up LIDARs, but also to build up like accuracy of centimeter level accuracy, because in many cases, indoors, for example, is one case, you don't have all these GPS, and for which the LIDAR. So what David was mentioning is true. Many of the startups that we're seeing are making, let's say, breakthrough products in LIDAR technologies and things like that, which are at the heart of the sensing capabilities that you have. And I think this is also a big shift from the classical communication, I would say, community, which was mostly focusing on the fact that electromagnetic waves were mostly used for sending bits, whereas today the focus is mostly about using electromagnetic waves to basically see the environment, do radio frequency imaging, for example, and be able to reconstruct in a 3D manner or shape the environment. The second, of course, is the connectivity. And I think also that here we're seeing also a lot of new challenges in the way we used to define basically the notion of, let's say, communication. If you look back at the Shannon's work of 1948, we're mostly looking at capacity. And here what's happening is that we're having smart devices, or call them intelligent, whatever you're putting in here, and where basically you start having memory and data and computing capability, and for which the whole framework that was built by Shannon, in which there was no memory, is completely changed, in the sense that here what happens is that you start building a context in the communication. These robots go in a given environment, they learn, and with this contextual communication changes the notion to notions like semantic communication. So we're seeing a lot of work being built here on defining new trends of notions where basically you need to transmit less bits to have the same impact in what you're doing, because you have built up a context. And we as human, we see also this thing happening in the sense that when you're with your wife or you're with your husband, you don't need to say all the things to have that thing, because there's some kind of contextual thing, and this is called semantic communication. And I think it's also, and the last one is of course the issue of let's say connecting these intelligence and how you connect. I think the protocols that we've been building and the IP protocol that has been built so far is around basically devices where humans are behind, and we need to reshape basically the IP protocol exactly for these billions of, I would say, intelligent devices, and for which there's drastic need of changing the latency requirements and other issues. And I think these are the triptych I see which are ongoing today to build up basically the network for having that. Said that, of course, in the AI, and I'll finish by that specific field, we obviously know, and I'll finish by that, that what is called AI today is mostly DNN, deep neural networks, and it's mostly brute force approaches. And we know that this trend cannot go far away again, and there's a need, to build up some new ways of doing, I would say, machine learning algorithms, which are more consumption friendly, and which basically take into account less, I would say, correlation based results, but more basically, I would say, invariant, the kind of things that we're doing. I mean, I can talk about it after if you want. I'll stop here.
Okay, thank you, Mérouane. So next is Gusz. Specific question for you is: do you believe that living beings are currently still needed to be in the loop to solve complex problems, or robots can do all by themselves? And if they can't, what are they still lacking to get?
Thank you. Just a reflection to the previous remark, okay? It is such a shame we are not physically present. I would really love to have a beer or a wine later on and discuss everything.
Yeah, we'll organize this again, TII, with all of you. That's for sure.
Would be nice. Anyway, so to your question, yeah, the complex task. So as we know, the border of complexity is shifting. In the dawn of the computer era, arithmetics was possible, done by a computer, but chess playing was not. Now chess playing is trivial, and a lot of other things are not. So, like, what is a complex task? Like putting the stuff after breakfast, all your plates and everything, in a dishwasher. Is that complex? Think about it. A dog, for instance, it does have the intelligence to do that. It doesn't have the limbs and the dexterity to do it. So it is too complex for a dog for reasons of, body reasons. For a teenage boy or girl, it's also too complex, okay? They do have the dexterity and the limbs, but it is beyond their, so they have mental problems with it. And a robot could deliver us the best of both worlds. So I think that there are tasks that are really genuinely complex, or at least at the current level of technology, demanding, and robots would be completely capable of doing them if, and this brings me to the second half of your question, what do they lack? I think what they lack today is morphological intelligence. Okay, so we had 40 years of AI purely trying to get thinking machines. Okay, now we are trying to do acting machines. And the difference between purely thinking and acting is embodiment, embody. And the morphological intelligence is a new notion, and we don't know much about it, but that's what they need in the first place. And the second one is the good old integration, obviously. So they have to integrate the morphological intelligence, the digital thinking intelligence, the sensors, the actuators, the planning and everything. And to this, and it connects also back to the current state of AI, overly dominated by machine learning, I think the next wave would be inverted. Rather than machine learning, it will be driven by learning machines. That will develop all these morphological and digital and thinking intelligence themselves. I finish here because
yeah,
I want to leave the floor to others. Yeah.
Yeah, I will go too far, but yeah, I mean, intelligence is the leitmotif of all your answers till now. So let's go back to Vikrant, and you mentioned before, you talked about the human factor especially for the acceptance, the human acceptance of autonomous vehicles. So how would you describe this user acceptance now in your operation of public transport, for example, at Local Motors?
Yeah, so we we have deployed over 25 different places with our shuttle and are continuing to grow. And I would start with two extremes, right? One extreme of user acceptance is people are very progressive and are willing to try autonomous vehicles, as an example, okay? The other extreme is extremely conservative, don't trust technology, don't trust the processes, and are quite skeptical about autonomy, okay? And what my view is, we are actually seeing the acceptance of autonomous vehicles evolving quickly and rapidly. What I have personally experienced is, when we have taken people who are not comfortable with autonomous vehicles and they ride in one, they come out moving to not to the other extreme totally, but closer to the other extreme. So my summary is, Enrico, is that that is one shift that's happening. When people experience something, they get more comfortable with it, they start believing in it. Now, there are two other elements that I believe are playing a role. One is the speed at which the vehicle is running. Right, and this is where I believe the segment we are focused on, and I'm not trying to do a sales job here, is the right focus, because we are running less than 25 miles an hour, and people are more comfortable running in an autonomous mode at that speed than running at 55 or 75 or 80 miles an hour. That's one element, right? The speed and the, at least the mental satisfaction of having control at lower speeds, which may not be always true. The second is, I do believe there is a generational shift happening. And, the younger generation, I believe, is much more accepting of autonomous, right? And I'm making an average statement here because their mindset is already there, right? So if I were to just summarize, I think the acceptance of autonomous vehicles is moving to the right. If I would say left is from anxious, right is to progressive, right? And we have to continuously focus on safety, right? Prior to anything else, to continue to build on that confidence that we are putting in the marketplace. The last thing I'll say, and I'm not I cannot figure out why. One thing is, if you have an autonomous vehicle makes a mistake versus a human-driven vehicle makes a mistake due to human error, our acceptance of the human error is a lot greater than our acceptance of the autonomous vehicle, right? And we, over time, will move, I do believe very strongly, we will move people's perception and demonstrate that running autonomous vehicle is safer, is more productive, and is good for all of us. So that's my summary of your question.
Nice, Vikrant. Yeah, you posed some interesting topics as well. And yeah, I mean, it's true. I mean, we think of humans as someone who can fail, whereas a machine cannot, right? So we are much more used to have a human failing than a machine. So yeah, it's something. Yeah, I don't know if you want to comment on that, but
yeah, I think I don't want to use the word struggle, but I'm going to use it. I think we as humans are struggling with the view, and we have a lot of bright people on this session, so I want to be careful, right? We are struggling to accept that the machine is more capable than us, right? Yeah. And that may be one of the reasons, to your point, Enrico, that we are okay with humans failing, but we are not okay with machines failing. And I think it was said earlier, in the past, we were expecting machines to think, nor are we expecting them to do. So the doing factor is the big shift that we have to make. But I agree with you, yes.
Yeah. Okay, thank you, Vikrant. And let's go back to Davide. Still a question concerning the present, and I mean, coming from the vision community, can you give our audience an idea of how the vision, the high-level description, an high-level description of how the vision differs from the way humans process the same information in respect of a robot, and how this information is understood and treated by robots?
Well, first let's think about what type of applications for which tasks is robot vision used. So if we think of autonomous cars, actually cameras are mostly used for detecting traffic lights and semantic understanding. So basically segmenting out all the pedestrians, all the other vehicles, cars, bicycles, facades of buildings, the road infrastructure, lanes, and so on. And they do this in combination with LiDAR, but we know that LiDAR still has a very low resolution. Now, instead, for drones, vision is mostly used for motion estimation called visual odometry in combination with inertial measurement units. And now it starts to be used also for drones for other things, like for depth estimation, so mapping, 3D reconstruction, as well as for semantic understanding. And I'm thinking of Skydio there more than DJI. In which way does robot vision differ from human vision? Well, human vision is definitely not computational. We do not build like metric maps where we build topological maps. Although if you ask any human, including a kid, to draw a map of your house or your building, your office environment, you will be able to draw it, right? Okay, so but in our brain, we do not have a metric map in the way that a robot actually memorizes it. So a robot in that sense will be able to use those maps in order to actually repeat the same maneuver over and over again with repeatable accuracy. So this a human cannot do at all. On the other side, we have a much more powerful neural network than our artificial neural networks. And some people like Schmidt-Huber believe that this is just a matter of layers, and suddenly one day the artificial neural networks will basically realize, you know, it can do also the same task as a human. But I mean, I don't know when this will happen, but for now we have to live with this. So current neural networks at the moment can do tasks that already are useful. For example, recognizing pedestrians, users. I'm thinking of, for example, Skydio that uses the drone to follow the user or multiple users, as well as for some gesture recognition. But they're not very mature. They are still struggling with things that they didn't see in the training data. So it will crash against dynamic environments because they do not tackle dynamic environments. It will still crash against the tiny branches of trees and so on. I'm thinking about drones, where actually, you know, vision is not currently mostly used for navigation. Why? Because for cars, we are still using mostly LiDARs for navigation. So in that sense, we are still very far from human, and actually going from 99% accuracy to 99 followed by another 109, well, it's going to take several years or decades.
Okay, nice. Thank you, Davide. And I apologize, Costas, I left you alone for a while, but it's because I wanted to conclude the questions on the present, diving again in the ocean with a question for you related to the most promising communication technologies for ocean autonomous exploration.
Okay, so, well, regarding ocean exploration, I don't think it's one robot's job or one man's job. We need to form a network. We need to have collaborative, heterogeneous robots doing this job. And in order to have that, since we're talking about heterogeneous robots, meaning that different companies will produce different components, and these need to cooperate and coexist underwater in order to do ocean exploration. We need to have some sense of interoperability, which is something that is lacking now in underwater. And in order to have interoperability, you need to have standards. You need to have standardized communications. And this is something that the community is pushing now, to have standards, communication standards. We now in the underwater world, we have one or two maybe standards. CMRE, my institution is the custodian of one of them, which is called Genus, and is actually the first digital underwater communication standard. And this is a very exciting thing that is happening now in the underwater domain world. Of course, I mean, speaking about you know, being excited about telling you that, oh, we have a standard underwater where there are gazillion standards in the terrestrial world. You can imagine, let's say, how far behind we are in the underwater domain, in the sense how capable we are to transmit information underwater. We are kind of living in the world of the 70s, when we have the modems of the 70s. This is what is happening now in the underwater world. Nevertheless, now, I mean, 10 years ago, if you would go and buy a modem, an underwater modem, that would be rigid, that would be monolithic. Now we are moving towards software-defined modems. We want to have the flexibility to be able to switch communication waveforms depending on the environment where we are and what are the challenges there. So this is what the community is trying to push forward, having like software-defined communication stacks that adapt from the physical layer all the way up to the application requirements.
Mm-hmm. Okay, thank you, Costas. So this concluded the present, and already there were so many ideas floating around that I can't imagine now that I will ask you questions about what do you think about the future of what we are talking today. So let's start again the round with Mérouane. Mérouane, you know, in the public opinion, it seems like Huawei is maybe the only one, or for sure the most effective in 5G designing the world, right? In deploying 5G everywhere. Do you think, I mean, if you had to sell a 5G system for someone who produces robots, how would you sell it? What is the deploying application that you could do with robots? Yeah.
Okay, so I don't think Huawei is the only one. I think with what's happening today, I think there are much more, I would say, manufacturers which are now providing 5G. So yeah. I think the big difference that we had with the previous generation is that today 5G is considered not anymore as a technology, but more or less as a platform. A platform basically where all the different, I would say, verticals, and robots are being considered as verticals today, can be plugged in, and basically within that system, okay, of what was considered 5G, providing you that latency requirements, providing you that connectivity, and also, which was mentioned, which is very critical, is this ultra reliable low latency communication. I think that was a major point that was at the heart of 5G. Although today, the majority of networks which are being deployed in the world, one, which is the mobile broadband aspect, the 5G phase 2, which will embed the massive connectivity and also the extreme reliability, will only come starting next year in some places, and which means that it's going to be taking more time. So I think this is, I think, the main thing is that 5G today is more a platform enabling those things. Now, the main issue we can see today is the problem of coverage with 5G, meaning that if you start building whatever system you want, and autonomous vehicles are one, with this hybrid scenario of having at the same time a bit of network control and also, let's say, user-centric or device-centric autonomous, then running a car from Germany to Spain is still an issue in terms of coverage. As you know, covering the whole territory is not something you can do, and then you need to reduce basically to some cases. And I think as long as we don't get that global coverage in different spots, we will still have an issue of deploying a massive scale of robots at each point. In many countries, even 4G or even 2G is not nationally deployed, meaning that you have some sweet spots where basically you go, and in the forest, you won't have your drone running over there. And what I mean by that is also basically device-to-device communication. I mean, it's not just the fact that you're linked to the network, but also basically having the bandwidth, the frequency deployed, so you can incur basically those different aspects. And so in a summary, I think that's how I would sell it. I would sell it more as a platform. And this is what has driven also the need of 5G, which is mostly about this industry more than the humans that we're forecasting. Although it's not kicking in as far as we thought, especially with basically issues related to security. We haven't mentioned it for robots. I think hacking robots at a distance is still a big question today. There's many issues which have not been tackled yet. And IoT, for example, which was at the heart of 5G. I mean, if you take the generation, 2G is mobile for voice, 3G is mobile for data, 4G is mobile for internet, 5G was mobile for things. It's not kicking in. What's being sold today is still the classical mobile broadband and phone business. And so we're still having an issue of how to make money. And this is in general the sweet point. How do you make money out of these robots and out of this 5G in terms of revenues for the operators, which are providing basically the infrastructure and the connectivity out of that?
Yeah. Okay. Thank you, Mérouane. Very clear. And so I will move to Gusz. Again, a question that will deserve a good glass of wine, because it's maybe the most philosophical one. So yeah, I would like to understand in the future if we will still reason as us humans and them robots, and if you think that they should become like us or not.
Indeed, that's a very good question for a good bottle of red. But seriously speaking, so when I think of the future of robots, I have also not only a professional but an intuitive image of them, and that intuitive image is nothing like the Terminator. If anything, it is closer to the dolphin, because it is like another form of intelligence. They share the same planet. Maybe there will be a lot of them. They are intelligent, but in my perception or expectation, they are friendly. They are different, the kind of younger brother of us. However, I really think that there is a huge difference between them and us, and I would really not. I am not trying or willing to remove this border, because they are just machines. And even some of my best friends love their cars or love their 10,000 euro hi-fi installation, which is a bit odd for me, but I can understand that. I can imagine that a robot will also raise some emotional attachment, but it will always remain a machine. And if kicking your car when it breaks down is okay, then kicking your robot when it breaks down should also be okay. And in this country, many people don't know, but in this country there is a party in the parliament which is called the Party for Animals, and I don't mean the hooligans or whatever, that's really genuine party for animals. I can very much imagine that in this country, in 25 years, there could be a party for robots, which is their right to have it. But nevertheless, I don't think this is a development that I would subscribe to. And I just realized that although I'm usually very far from any form of chauvinism, you may be calling me a carbon chauvinist. And I really think that life as we know it is different from artificial life as we could get it.
Okay, thank you, Gusz. And so, I mean, after we speak of dolphin, Costas, I guess it's your turn to respond to the next question. And yeah, I mean, human activities are moving more and more into the deeper waters, and at the same time, we are increasing pollution and other problems with the oceans. Do you think that somehow some of the challenges of underwater communication and robotics can go in the direction of alleviate these problems, and which are the challenges you see in general?
Well, let me also say that, I mean, when we talk about the underwater world, it's not only the pollution about, polluting the water because you release substances from from factories or plastics. It's all about generating sounds underwater from sonars or from the ever-increasing shipping activity, which is also has increases the general soundscape underwater. So pollution also in the sound is also very important in the underwater domain, not only about the water pollution. Now, regarding the challenges, well, let me first say that in the underwater domain, we mainly relying on acoustics, because this is the modality that allow us to convey information for tens or hundreds of kilometers. Radio signals or optical signals, they attenuate very fast. With optical communications, you can hope to go 50 or 100 meters in less turbid waters. So we are basically talking about acoustic communications in the underwater domain. And of course, they have their own challenges, because if you compare acoustic communications with RF communications, you can really don't apply what is happening in the terrestrial world underwater. It's a very bottom-up procedure. You need to develop your own ideas from scratch. Just to give you an idea, I mean, the multipath that you experience in underwater it can be easily 4 or 5 orders of magnitude larger than what you experience in the cellular world. You have noises that are coming from marine mammals or other sources, depending on where you are. So it's really a challenging problem to communicate underwater. That's why the speeds and the data rate that you get is orders of magnitude lower than what you get in the RF world. Having said that, the problem is that one of the major issues, and we are hoping to solve, is that we don't actually have standards, channel standards underwater. I mean, you have all these nice 4G, 5G standards, IEEE 802.11 standards in the RF domain. In the underwater, there is 0 channel standards. What does it mean? That we cannot have reliable simulations. We cannot go in our PC and have a reliable communication simulation and get performance. We really need to go to the sea and conduct an experiment and measure performance. So this is something that we are working on, generating standards. Another big issue is that big difference between underwater and RF is that we don't have spectrum management underwater. There is no spectrum management at all. Everyone can go and transmit whatever he wants, whenever he wants, wherever he wants. So it's kind of the Wild West in the underwater domain. So that's an issue that is also legislative, and I hope that will be also solved. So, I mean, when it comes to robotics, AI and localization navigation, these are open issues due to the lack of, let's say, due to the poor communications. The vehicles underwater, they really need to rely on their own sensors, and they really need to stay unattended for a long period of time, because they don't get communication signals as often as they wish. So they really become autonomous in the underwater domain. They really need to depend on their own sensors, on their own payloads, and do the signal processing on board in order to navigate underwater. So this is a big challenge. Yeah, pretty much this is my answer.
Okay, thank you, Costas. So I will go back to Davide with the vision part. As we have mentioned again, problem underwater would also depend a lot on vision. So, I mean, vision is the richest sensor information we have as humans. So is the same for robots, or, I mean, they have better sensors to perceive the environment around? And up to which level you think we can enrich the vision of robots in the future?
Yeah, I mean, it all depends on what we define as better. In terms of resolution, spectrum, of course, cameras, spectral cameras are doing already a very good job, or are already superhumans, right? Because we humans do not see, for example, in the near infrared or ultraviolet. So they are already superhuman. Now, so that is the domain of the spectrum, but we can also think about the domain of temporal resolution. So if you think of high-speed cameras, they are already better than the humans. The problem is that, so actually they can go up to megahertz with resolutions of, I think, 64 by 64 pixels. I'm thinking of the Phantom camera. However, then they need a lot of external illumination. They need also a large SD card, because typically these high-speed cameras can only record a phenomena that lasts for a few seconds, okay? However, now in the last few years, there has been a new sensor that was invented actually in my department by Professor Toby Delbruck, which is called the event camera. An event camera is basically still an optical vision sensor, however, where the pixels do not integrate photons over time, but rather they respond asynchronously whenever a single pixel detects a change of intensity. So basically, every pixel reports the sign of the derivative of the signal, of the visual signal. So it responds to the varying component of the visual signal rather than to the stationary component. So the advantage of these event cameras is that because they are a differential sensor, they can actually have latencies up to fractions of milliseconds. Actually, without jitter, in principle, they have a resolution of 1 microsecond, but with jitter, they can go up to 100 microseconds, which is already superhuman. And this is great for all the high-speed applications. For example, if you want to be able to detect people jumping on the street from different sides of the vehicles, especially from the sides where actually there is the largest apparent motion, so you want to install event cameras looking at the sides, they are very, very beneficial for that. They can also see better in low light, as well as especially in bright light, especially when the sun is in the field of view of the camera. Reportedly, they have a dynamic range that is 8 orders of magnitude superior to standard cameras in that. And then they also have been found to consume very little power, up to 100 or even 1,000 times more than a standard camera, which is very important now for edge computing applications, where actually you want to be able to do everything, you know, on the edge and consume as little as possible. I'm thinking of monitoring applications and so on. So this is where vision is going. Of course, when you want to compete with LiDAR, still LiDAR can see and measure distances up to 300 meters. So that's what a camera or a stereo camera cannot do unless you use triangulation. Then you have a huge baseline of at least 20 meters, which is bulky. So with LiDAR, you exploit the time of flight principle, and this is much better, of course. Okay, but then there are also light field cameras that exploit the fact that basically you can put the tiny lenses, millions of tiny lenses into an optical device. So there are many new sensors that are already superhumans. We just have to find a good application for them.
Okay, thank you, Davide. I was just informed that our Zoom call will finish at 10:30 my time. That means we have 10 minutes. So I ask you to respond in 30 seconds to the last question that I will ask you. So Vikrant, actually for you, it's 2 quick questions. The first is the specific one for you. Do you think that we will finally see a massive deployment of autonomous vehicle? This is the specific one for you. And then a more general one that I will ask also Costas and Gusz to respond is, do you think that putting together different disciplines like control, vision, communication, AI, robotics will make things work? I need a 1 minute answer, sorry for pushing.
So I'll just quickly answer. My view is, I read an article recently said, is your city budget ready for AVs? It's time to plan for their arrival. Okay, that summarizes my answer. I think we will see growth in autonomous vehicle deployments. When we will see a big deployment, if I could answer that and predict that, I would be retired, but I do believe we will see one. I think in terms of the second question, I really do believe, bringing all these interdisciplinary capabilities together will enhance the whole robotics space. The challenge will be, and the opportunity will be, how do you make all those things dance together to have a perfect union? And that is going to be the challenge, and that's going to be the opportunity as well. So thank you again for the opportunity today.
Thank you, Vikrant. So same question to Costas and Gusz. You can even answer me with a yes, because in the end, I mean, putting together all these disciplines is what we are doing actually at the ARRC. So, I mean,
yes, Enrico, I'm done. No, I mean, I just want to say really quick that, I mean, we had a very nice example today in the first keynote, speech by Professor Lasci on soft robotics. They presented how and a very nice collaboration between roboticists and biologists in order to generate this very cute soft robot that can sustain very large pressures in the Mariana Trench, if you recall from that presentation. So that was a very nice example of a collaboration between a roboticists and biologists.
Yeah.
I mean, when it comes to to navigation and localization of underwater vehicles, of course, it's a multidisciplinary action by itself. You don't need only the roboticist, but you need the signal processing, you need the acoustician that will tell you what is the environment. You need, if you're having a network, a cooperative localization, you need networking guys and communication guys to do this networking. So, of course, it's multidisciplinary. Thank you also for the invitation.
Thank you to you, Costas.
It was really a pleasure to be among you.
Same question, Gusz, again.
Yes, okay, so you have my yes, that's a no-brainer, but I would say you don't go far enough. You have you need all these, and you need evolutionary biologists, you need child psychologists, you need movement scientists, and increasingly you need ethicists.
Yeah.
Okay, so, okay, I stop here to leave floor for everyone. Thank you again. A great vibe, and I hope to see you guys in real life once.
In Abu Dhabi soon. Yeah, I hope so too. So, Davide and Mérouane, 30 seconds for you. Use case, future use case. So, Davide, first 30 seconds. Davide, sorry for the hurry. Future use cases of autonomous robots. You are
actually
okay. Yeah, it works.
We are going to see more and more drones performing autonomous operations like inspection of bridges, which at the moment they require actually the user in the loop. I believe very soon, like already maybe next year, there are going to be already use cases where autonomous drones like Scadio will be able to do full autonomous inspection, okay, because they are already endowed of this possibility. Autonomous cars will not come before 2050 or 60. It's level 5 autonomy. Sorry.
Okay, good discussion for Vikrant as well. And Mérouane, 30 seconds for you to conclude and wrap up the whole panel.
Yeah, I think, so first of all, yeah, interdisciplinary research is important. However, I think what's missing today is more breakthrough in the disciplines of those different, I would say, research trends, because we're seeing more adaptation of what they're doing to the realm of what we're doing. I mean, I think signal processing, we know that there's a lot of nonlinear effects, and there hasn't been any breakthrough in nonlinear signal processing. So I think there should be, in both hands, at the same time, the interdisciplinary research, but also breakthroughs which have to be done within those fields and moving. Mathematics is the same. AI is mostly correlation classification based. We need other new tools to be able to push that. Now, in terms of use cases, I think something which has not been mentioned too much, but Gusz was talking about it, is more or less what's interesting for us is the interactions in a world where we have robots and humans, and not just robots between them. And I think this is the big thing. And you see it when Amazon deploys robots. You need to move as a human with robots around you and avoids collisions and everything. And I think the fact on how we're going to build this thing is going to be a major challenge.
Okay. Well, thank you, everybody. It was really, really good to hear your opinions, and I think that we are recording this panel, and we will listen to it again and again. We'll make a small Netflix series out of it, I think.